Good morning, everyone, and welcome to the first Reefs Go live broadcast of 2026. We're very excited for you to be joining us on the first broadcast, and we're welcoming you from. I'm broadcasting from CCMI on Little Cayman in the Cayman Islands, and our underwater crew is behind me, in the reefs behind me, which are known for frequent sightings of Nassau groupers, stingrays, nurse sharks, and occasionally sea turtles. So for a quick introduction of today's team, my name is Daria Siciliano, and I'm the head of Marine Science Education at CCMI. And joining me from underwater is Anna Berry, and she's going to be your underwater host. She's wearing a specialized full face mask that allows her to be hearing me and to be talking underwater. Shall we go down and meet Anna?
Hi everyone, and I'm so excited to have you joining us for the first Reefs Go live episode of 2026. And just take a look around here. We have an absolutely incredible location for today's episode. The reefs here in the Cayman Islands are absolutely teeming with life. Here at CCMI, we've been studying these reefs for 28 years, and we would spend all day here talking to you about them if we could. With that in mind, we would love to hear your thoughts, comments and questions. Please put them into the chat, and we're going to do our best to respond to as many of them as possible. To kick things off, I'd love for you guys to put in your name and your favourite species of fish.
We have viewers from all over the world joining us today, and I wanted to say hello to them. But first, I would like to introduce you to the team off camera that is working really hard to make it all possible. Would you like to say hi, everyone? Perfect, thank you. So before we begin, let me send a shout out to some of you joining us. I'd like to say hello to Kim from Georgia in the United States, from grade 2 at Cayman International School, from year 6 and 5 at Footsteps in Grand Cayman, and from Miss Glover's class from Bailey's Court in the United Kingdom. So wonderful. So thank you everyone for joining us, and we're ready to let's dive into the first Reefs Go live episode of 2026. Over to you, Anna.
Did you know that whilst coral reefs cover only 1% of the ocean seafloor, they're home to over 25% of all marine life? Here at CCMI, we think that's pretty impressive. When scientists talk about biodiversity, they're referring to the number of species which you can find across a certain area. Coral reefs are really impressive because they have such high biodiversity, which is why you sometimes hear them referred to as the rainforests of the sea. If I'm just looking around me now, I can see blue chromises, damselfish, angelfish, parrotfish, and that's just here in this small section of the reef. And it's not just the fishes either. Coral reefs are also home to hundreds of species of algae, sponges, corals, and invertebrates. And as well as being so incredibly biodiverse, these amazing areas also are some of the most colourful systems that we have on this planet. Daria, do you want to tell us a bit more about some of the incredible colours that we're seeing around us?
Absolutely, Anna. Color is such an important aspect of coral reefs and marine life in general, and it's used for many different aspects of marine life. So it's used, for example, for communicating, for scaring off predators, for attracting mates, and perhaps the use you're most familiar with is for camouflage. And it's the interesting thing is that it's not just like species have one color and one look. They actually change color and patterns over time. So for example, some species may change color as they grow older. So the juveniles of some fish may have a certain pattern and colors, and the adults of that same species would have different colors and patterns. Or sometimes fish change colors because of their mood, which I think is pretty cool. And other times fish change colors because they want to blend in with their environment. So it's all very interesting, but I would like to go back to you, Anna. Can you tell us a little bit why it's so important to have all this color, vibrant color in biodiversity on our reefs? Over to you, Anna.
Well, Daria, that's what we're going to be getting into. In today's broadcast, we're going to be talking about how marine species use colour to survive, and what makes biodiversity so important to coral reef health and resilience. But before we get into all of that, we would love to hear from you guys. What do you think makes biodiversity such an important part of these coral reefs? Let us know in the chat now.
Great, wonderful. So I'd like to ask all of you at home again to send us comments in the chat to tell us why biodiversity is so important. And I'll read some of your comments shortly. So biodiversity is important because of the medicines that we get from the ocean. Biodiversity is important because it helps protect the health of the reefs over the long term. Absolutely. So there's a lot of excellent comments on why biodiversity is so important to our reef system, and we're going to explore over the course of this episode additional reasons why that is. In fact, I would like to go back to Anna, who can tell us a little bit more how biodiversity helps keep reef ecosystems strong and healthy. Over to you, Anna.
Any community of plants and animals which interact with each other and their environment is what we refer to as an ecosystem. Coral reefs are really unique ecosystems because of the sheer number of species which we have interacting over a very small area. In order for this to work, all of the different species have their own special jobs to do, kind of how humans will all go to work at different jobs. When we're referring to ecosystems, we call these roles ecological niches. An ecological niche can include where a species lives, what it eats, who its friends are, and who its enemies are. Having all of these independent and unique ecological niches is what allows all of these species to coexist within a very small area. And for coral reefs, it's the corals themselves which allow for such high biodiversity and for so many niches to exist. Daria?
Thanks, Anna. Yeah, so corals, in fact, actually provide some very important role in reef ecosystems. And we're going to be taking a closer look at 3 key roles for ecosystem with a really cool graphic.
Corals have 3 key roles in keeping reef ecosystems alive. First, they help power the reef. Corals might look like rocks, but they're actually animals. Each coral is made of tiny animals called polyps. Inside each polyp live thousands of microscopic algae. These are called zooxanthellae. These tiny algae use sunlight to make energy, and they share that energy with the coral animal. When a fish eats the coral or eats something that depends on coral, that energy moves through the reef. Second, corals build the reef's structure. As corals grow next to each other, they build the physical framework of the reef. The holes, gaps and crevices they create become shelter for other reef organisms. They provide hiding places and safe spaces for fish of many different sizes. The third key role corals play is protecting the coastline. Their hard limestone skeletons form a barrier. When waves hit the reef, much of their energy is absorbed and broken up. This creates calmer, shallower waters behind the reef that make safer nursery areas for young fish. Together, these roles allow coral reefs to thrive.
Great, so we've seen 3 of the key roles that corals play in coral reef ecosystems. And it's important to note that actually coral reefs stay healthy because there's many different species that play their ecological role, carry on their own ecological role or niche, as we call it. So let's go down back to Anna's, and she's going to help us find some examples. Over to you, Anna.
With pleasure, Daria. Let's try and find some examples. Over here, you can see we have some of our herbivores, like these bicoloured damselfish, which I'm pointing out. These guys are really important, and what they're going to do is they're going to graze on all of this algae that you can see around the reef, and leave space for corals to grow and for coral babies to settle. This is a really important role, because the corals can't move around. So they are dependent on these herbivores to control the amount of algae that's growing around them. If the algae is allowed to just grow freely, it can completely take over and kill the corals. Then we have our slightly bigger species, such as our jacks. And these guys are omnivorous, which means that they'll eat these small herbivores and basically be a control, allowing for there still to be enough primary producers on the reef. And then we have our apex predators. Here in the Cayman Islands, the main ones that we get are our reef sharks, our nurse sharks, our lemon sharks, our southern stingrays, and our eagle rays. These guys are really important. When you have healthy populations of apex predators, it's a sign that the coral reefs are doing really well. Like the groupers and the jacks, they're also going to help to control populations. But because they're so much bigger and they travel so much further, they're not going to bother with these small herbivorous fish.
I'm glad you brought that up, Anna, because a niche isn't just what an animal eats. There's many different factors that go into it. For example, size is one of them. And of course, that affects diet of different fish. So for example, take some herbivore fish. You have some bigger herbivores that may be eating algae that are the larger algae, the seaweed, so they're really controlling the seaweed on the reef. And then there's some smaller herbivores that may be scraping some of the turf algae off of the coral rock to keep it nice and clean and allow some of the coral recruits, baby corals, to settle back onto the reef. So it's all very interesting. And I have a few more comments from some of you about why biodiversity is important. Because more fish make the reefs more beautiful, more colorful, absolutely. Because bigger animals, so different larger species need fish to survive, absolutely. Tristan says that it helps the food chain to have high biodiversity. And also biodiversity is important because it helps provide a home and food for many different ocean species. And these are all very good, very interesting, correct points that you all raise. And of course, we still need to go back and talk about color, which is the topic of today's episode. And coral plays so many important roles in both shallow Notice that when we're talking, when Anna is talking to us down at 10-meter depth where she is on the reef, everything looks blue, kind of had this bluish tint. And that's because different colors are absorbed differently when light hits the surface of the ocean, which is when light hits the surface of the ocean, some of it is scattered and some of it is absorbed, and different colors are absorbed at different depths. So, for example, red, the color red is absorbed in the first couple of meters, and in certain types of water, even in the first couple of centimeters. And then the next color to disappear, to be absorbed, is yellows, and then green, and the color that penetrates deeper is blue. And that's why everything looks kind of bluish where Anna is at 10 meters depth. So where Anna is and all the way in the ocean where light still reaches, we call that the photic zone. So that's the zone of the ocean down to about 200 meters where light still occurs. So shall we go back to Anna in the photic zone that can tell us more about this? Over to you, Anna.
Yes. Because so much light reaches down to these tropical depths, many species will have special adaptations which involve colour. Uses for colour include communication, camouflage, warning, and mating. And because colour is such a big part of adaptations in tropical reefs, it also forms part of the ecological niches of species. For instance, species which live higher up in the water column will often have a silvery colour, so that if there are predators swimming below them, they're well camouflaged, whereas the species which live down in the reef itself, they will often have dark bars or horizontal bars or stripes, which essentially break up their silhouettes and allow them to hide in small gaps in the coral. And then there are certain species which will change colour depending on the time of day that they're around. For instance, the squirrelfish has a dark red colour because it's most active at dusk and dawn, which allows it to hide most effectively when the light is low.
Because red is the first color to be lost. So those squirrel fishes won't actually be seen at depth if they're red. That's very clever. Yeah, and then I just wanted to note also that some fish do the opposite. They actually have very bright colors, and they have a different strategy. And my colleague Amy was out here on these reefs a little earlier, and she actually has some footage of that strategy, this other strategy about fish with bright colors. Over to you, Amy.
Okay, check this out. In front of me, we have a lionfish. And the first thing you notice, its stripes. They're red, white and brown, and impossible to miss. And that is exactly the point. You see the spines on top? They're venomous. See, in nature, these bright colours so often mean warning. They're telling other fish, do not come near me because I am not an easy meal. But what's so special about lionfish is that they don't just use this to deter predators. They also use their colours to confuse prey. The lines make it really tricky for smaller fish to distinguish the outline of the lionfish, meaning that they can get so close to this fish without them even knowing. They move slowly, and when they get close enough, they pounce. They are wonderful, and they are completely powered by colour. Now I'm going to hand you back to Daria and Anna, who are live on these very reefs for you now.
Thank you, Amy, for that. That was really interesting. And I just wanted to note that sometimes some fish actually mimic those bright colors, not because they're venomous or dangerous, just as a strategy to protect themselves. And that's especially true for juvenile fish. Over to you, Anna.
Yes, and that's another really interesting point. Often a species will look completely different as a juvenile compared to when it's an adult. This is because the juveniles are so much smaller, they face a completely different set of competitions and pressures when compared to their parents. Let's look at the stock-like parrotfish as an example. As a juvenile, they'll have dark brown and black scales, which allow them to hide effectively on the reef. As they become adults, they start showing their vibrant colours, because they're big enough that they don't have as many predators, and it's also a sign that they are sexually mature and ready to reproduce. In fact, there There are many species which will use vibrant colours as a sign that they have reached sexual maturity. Here in the Cayman Islands, we have one of the last remaining spawning aggregations of NASA groupers in the Caribbean. Every year, at January, around the full moon, the NASA groupers will gather at one spot on the island to reproduce, and during this time, they'll display a brown colour with a white underbelly to show that they are sexually active. And it's not just the fish which have these incredible colour adaptations, it's the corals as well. Daria?
Yeah, but coral color is actually a little bit of a different story. So corals get their color from their zooxanthellae, this microscopic unicellular algae that live within the tissue of the coral. And they basically have a mutualistic, symbiotic relationship with the coral. So the coral, the zooxanthellae provide the coral with about 90% of their food, the food that they need, and therefore the energy that they need. And the corals, in turn, provide the zooxanthellae, the algae, with a safe home. So without the zooxanthellae, the coral, which is actually translucent, it doesn't have any coral. So when they expel the zooxanthellae, this translucent coral appears white, because what you see is the rock, the coral rock underneath, which is calcium carbonate, and it is white. So sometimes this happens because of stress events, for example, sustained high temperature for long periods of time. Sometimes it's because of salinity, pH changes in the ocean. It's a number of different reasons, but this process of the corals expelling their zooxanthellae and turning white, because what you see is the rock underneath, the coral rock, the calcium carbonate rock. This process is called coral bleaching. So it's time to go back to Anna. And Anna, can you tell us a little bit more about what happens in the deep ocean now that we talked about the shallower coral reefs?
For sure. We actually know less about the deep sea environment than we do about the surface of the moon. But we still have some understanding of how deep sea creatures have adapted to use light and colour. Because no light reaches down to this zone, there's not much point having vibrant colours on your body. So many of the species will be translucent or transparent. But there are some species which use a chemical reaction to produce their own source of light, and we call this bioluminescence. One example of this is the anglerfish, which has an antenna coming off the top of its head with a light on the end of it, which it uses to lure in prey. And other deep sea species will use bioluminescence for things like mating, scaring away predators, luring in prey, and communication. So although the way that deep sea creatures present their light is very different to the way that reef fishes present their colour, their uses for light and colour are actually very similar.
Great. Yeah, before we continue, I just wanted to read a couple of questions from the ocean, from the chat, from all of those of you watching at home. How deep can you see the color red in the ocean? And that's a very good question. It actually depends on the type of water. You know, there's, for example, in the coral reef environments in the Caribbean Sea, the coral red maybe penetrates about a few meters, 2-3 meters at most. But in some other types of water, say off the coast of California, where the water is not as transparent as in a coral reef, the coral red is lost a lot quicker. So in the first few centimeters, depending on the type of water, like how much suspended sediments and nutrients you have in the water. So that's a really good question. Another question from Paisley: what is the most colorful fish in Cayman? There's so many choices. I mean, what comes up to mind is the spotlight parrotfish, which uses their very bright colors also to kind of like tell its mates that it's ready to mate and it's basically sexually mature. But there's so many different species that we could be mentioning. Let me go to another question from Havana. Which fish has the biggest color change from juvenile to adult? Yeah, I mean, going back to, is it the parrotfish? Definitely, if you see the juvenile of the spotlight parrotfish, it's this kind of brownish color. So that's a very different, coloration than the adult. That's a really good question. Okay, so I just wanted to kind of go back to what Anna was talking about and the difference between the shallow reef and the deeper reef. And one other difference between the shallow and the deep is the fact that the deep ocean is a lot more stable than the shallower ocean. So by that I mean that environmental factors don't change very much. So for example, take temperature. In the deep ocean, ocean temperature is quite cold fairly steadily, so it's always pretty cold, and so it's true for example, salinity, etc. As opposed to in the shallow ocean, there is a lot of fluctuations. Say temperature fluctuates between day and night. It also fluctuates seasonally, and we've actually also witnessed in the last few decades a steady increase on temperature, and that change in temperature, ocean temperature, is happening at a pace that is completely unprecedented, much faster than ever experienced by ocean ecosystems. So what this means is that coral reef ecosystems need to adapt to these changes, and their ability to survive completely depends on their ability to adapt to these changes. We call that reef resilience, the ability of reefs to withstand change and adapt to changes. So reef resilience is important to be able to have coral reefs persist and survive over time. So do you agree, Anna? Over to you.
Yes, and unfortunately, human impacts are starting to affect the coral reefs more and more. As we start to see higher average temperatures, we're also starting to see a greater number of coral bleaching events. In 2023, unusually high summer temperatures led to 95% of the corals in Little Cayman to become bleached. And similar patterns were seen all across the Caribbean. Now, the coral reefs can recover from these bleaching events. If temperatures return to normal, the corals will be able to recruit their zooxanthellae again. However, if the unusually high temperatures persist, or the corals start to face other pressures whilst they're already bleached, it can make them completely unable to recover and lead to the death of these corals.
Yeah, as a matter of fact, we have a question from the audience. If a coral is bleached, is it dead? That's exactly what I was going to tell you about. When corals bleach, they are no longer provided by the zooxanthellae. Remember, they're symbiotic algae that live within their tissue with the food and the energy they need. So essentially, when a coral bleaches, it's starving. If that period of starving, being without their zooxanthellae, is prolonged, lasts for several weeks, then eventually the coral dies. If the period when they are, to answer your question from the audience, if the period when they are without their zooxanthellae only lasts a few days, the coral can recover. It just gets back its zooxanthellae and survives. But if that period again is quite long, then the coral will eventually die, and what is left is that skeleton, their calcium carbonate skeleton, which is that coral rock, and immediately algae will colonize those dead corals, that calcium carbonate rock. And algae grows so much faster than coral, so algae will very quickly colonize all of the coral reef substrates, and they it's a real problem because they replace coral and they prevent coral recruits or baby corals to settle back on the reefs. They don't have that substrate to settle back on the reefs. So the result is that the reef will have a much higher, harder time to recover. So interestingly, reef fish play a key role here. So reef fish can come to the rescue to a reef ecosystem that has experienced bleaching. And maybe Anna can tell us a little bit more about that. Isn't that true, Anna?
Yes, Very true, and CCMI's healthy reef data shows this. We've been collecting surveys on fish and coral populations since 1999 and have one of the longest temporal data sets in the Caribbean. And after the 2023 bleaching event, we saw something really interesting. First off, for the 2023 data itself, we saw that across the 10 different site surveys, different sites had lost different amounts of coral coverage. And then when we were looking at the recovery of the reefs in 2024 and 2025, we saw that whilst half of the sites showed no recovery of coral coverage at all, the other half, the corals had started to recover. And this raised a really interesting question. On an island that's only 10 miles wide, 10 miles long by 1 mile wide, how come some reefs are starting to recover and some aren't? Why are we seeing such a big difference? And at least part of the answer lies in reef fish biodiversity.
Yeah, so as Anna mentioned, the scientific research that we do here at CCMI includes collecting data over many years and decades about both corals and reef fish. And we've been noticing an interesting trend over the period of time that we've been collecting this data. We noticed that as coral covers has declined, reef fish abundance has actually increased. And it's actually a particular type of reef fish that has increased in their population size, and those are herbivorous fish. And I think you might already know why herbivorous fish, those that eat algae, might have increased in their population sizes, because when a bleaching event occurs, such as the big global 2023-24 bleaching event, reef fish that eat algae, they have a lot more food available to them. So their numbers can increase because of the higher food availability. And when they grow in numbers, their ecological niche becomes bigger, right? So reef fish diversity is not just about all the pretty colors that you guys have all noted, but there's essential ecological roles that reef fishes fill. So there's essential roles that are very important for the fish to adapt to the changing environment. So I just wanted to note that oftentimes on the reef, you have different species that actually fill the same ecological role. So for example, they eat certain types of algae. And when we have multiple species fill the same niche, we call that functional redundancy. And that's not just true for fish, it's actually true for corals as well. The more variety of corals that we have on the reef, the better chance the reef has to withstand change because of that functional redundancy. Because if there is a bleaching event or some other stressor, some corals may struggle and may not survive, but others will survive, will adapt and survive. And so that's very important for reefs to be able to persist over time, having functional redundancy, multiple species filling the same ecological niche. So let's check back with our dive team before we answer some more questions. How is the team doing down there?
We're doing great. Let's dive into some questions.
So I'm just reading on the chat from Paisley, from Havana. What is the coldest temperature a fish can survive in? So we have Arctic and Antarctic fish, such as the ice fish or the Greenland shark, and they can withstand some, very, very cold temperature. Some fish has actually antifreeze in their blood, and that's an adaptation for really cold temperature. So obviously that is not needed in warm tropical coral reefs. The water is, warm, and in fact the problem is the warming on the ocean. But that's a really, really interesting question. What fish do you see a lot on Little Cayman? We're very lucky here in Little Cayman. We see a diversity of fish. We see lots of very colorful angelfish, wrasses. We see a fish that is actually almost disappeared in the rest of the Caribbean. It's called the Nassau grouper. As you know, as Anna's mentioned, it's a fish that historically was present in all of the Caribbean, and then it's been fished out. But in Little Cayman, we have the last spawning aggregation of Nassau groupers in all of the Caribbean, and so it's we're very lucky to see them on almost every dive here on Little Cayman. So those are all excellent questions, and so we can have a little bit of a recap of what we talked about today. We talked about the incredible color and biodiversity of reef fish. We talked about oceans are changing over time, and that change is happening faster than ever, and that I hope that you all appreciate how it's important to understand those changes in order to better protect the reefs and all of the ocean's ecosystems. Over to you, Anna.
There are so many of us who deeply care about the ocean and who are very impacted by changes to it. So we would love to hear from you guys. What are some things that you think that you could do to help preserve the incredible biodiversity that we have here on our coral reefs? We're going to give you a minute to pop your thoughts into the chat. But in the meantime, Daria, could you recap what we've learned about today?
Great. So while we wait for all of you to pop some of your comments in the chat, I just wanted to let you know and recap what we learned today. Today we learned how color adaptations allow many different species to survive both in the shallow ocean and in the deeper ocean. We also discussed how ocean biodiversity helps strengthen reef resilience. Remember that ability of reefs to withstand change and stressors and persist over time. And we also talked a little bit about how CCMI research, the research we do here at the Research Institute, has shed some light into how coral reefs can persist over time. So let me see some of your comments on the chat. Some of you have told us about some things that we can do indeed. Recycle and use less plastic, which is a huge issue on coral reefs. I mean, we often have beach cleanups, and it's amazing the quantity of plastic trash that we collect on the reefs, even remote reefs like Little Cayman, because plastic comes from, has origins away from where it actually ends up, like the pristine beaches of Little Cayman. So to preserve reefs, we also, remove plastics from the sea, or we use, this is a very important thought, we use less transportation that relies on fossil fuels. So some of you have said walking to school is a very good way to help the reef. That is very, very important. Walking to school or riding your bike, for those of you who have the possibility to do so. That's it's important to see the connection between driving and using other, other fossil fuel transportation means, and as opposed to walking or riding your bikes. Beach cleanups. I see Havana, International School of Havana, they were talking about beach cleanups. It's so important because when we don't remove it from the beach, some of those plastics will end up in the ocean, and then over time they'll degrade and become smaller and smaller and smaller pieces. And those pieces are so much harder to remove from the ocean. Those are called microplastics, and then they end up in the bellies of many organisms, fish and invertebrates, and then they move up through the food chain, even arriving as one of the upper trophic level fish in our plates. So it's a very, very big issue. And so I'm so glad some of you have very clear how plastic removal, beach cleanups, and not using plastic in the first place. So some of you have mentioned no plastic water bottles, right? So that's really, really great. So Unfortunately, it's time to say goodbye. Our time is up for today, and I hope you've enjoyed this episode and you feel inspired to continue to protect the ocean and care for the ocean. And I wanted to thank you for joining us today, and I also wanted to give Anna an opportunity to say farewell to our viewers. Over to you, Anna.
Guys, thank you so much for joining us today. We've had an absolutely incredible time, and we're looking forward to seeing you for our next episode, Superheroes of the Sea.